Welcome back for another session, and this problem has to do the same thing with the cyclotron. As the usual, we have a diameter and we have a volt, and we have to look for the kinetic energy, and they give us the magnetic field strength. So what are we gonna do? First thing first, we're gonna find the speed, and the cyclotron formula to find the speed has to do with the radius, and that's R equal mass multiplied by speed divided by charge multiplied by the field strength. This is the first step. So the radius of, we have the diameter, that's 65 centimeter, and that's the radius is going to be equal 0.25 meter. Okay, so 0.325 is going to be equal, the mass of a proton is 1.6 times 10 power of minus 27 kilogram, multiplied by the speed, and this is what we have to find, divided by the charge of a proton, that's 1.6 times 10 minus 19 coulomb, multiplied by the field strength, and that's 0.75 Tesla. So the speed is going to be equal 24.375 power of 6 meter second. And we have to find from here, question number A, what is the kinetic energy? What is the maximum kinetic energy? We know that the maximum kinetic energy has to do with this formula, 0.5 times mass times speed square. So 0.5 times the mass of a proton, that's 1.6 times 10 minus 27 kilogram, times the speed, that's 24.375 power of 6 square. So the kinetic energy is equal to 4.75 multiplied by 10 power of minus 13 joule. Okay, question number B, they are asking us how many revolutions before the proton will leave the cyclotron, and this one has to do with the energy. So we know that the 1 electron per volt, it takes 4.75 that minus 13 joule for 1 revolution. And actually, hold on, where's back? If we multiply 1, actually one electron per 1 volt is 1.6 times 10 minus 19 joule. That has to do with the equation of the potential energy. That's the charge multiplied by volt. If 1 electron multiplied by 1 volt is going to give us this. So now the energy is 4. Okay, I'll do it again. So if it's 1 electron per volt is 1.6 times 10 minus 19 joule, and this one is 4.75 so this one is 4.75 times 10 minus 13 joule. We can do the crisscross formula. So we're gonna multiply by 1 and divide by 1.6 power of minus 19 joule, and this one will give us 29.68750 electron per volt. Okay, And from here, we know that 1 electron multiplied by volt, sorry, if the numbers if the number of revolution is equal of 29,68750, and we know that one revolution is 500 volts. One revolution is 500 volts, and because it's a cyclotron, we have to multiply by 2 for two sides, and this one is equal 1000 volts. So we're gonna take the number of revolution divided by the volt of two sides, and that's per revolution 1000 volt. So that's 29,68750 divided by 1000 volt. And now we can say the number of revolution for every 1000 volt for two sides is equal to 2968, not 75.